Hello class, this is Mr. Hart, and in this podcast we're going to continue our discussion of polynomials and learn more about factoring, and we're going to use a method called factoring by grouping. Okay, and so before we really get into this method, okay, we really want to understand what it means to factor something. Okay, and so you may have remember how to factor a number, but what do we mean when we say we want to factor a polynomial? So factoring a polynomial is very similar to factoring a number. Okay, it's kind of the same idea. So let's look at factoring a number first. Okay, so think about factoring. You just start with some large number like 72, for example. Okay, and you start breaking it down into its separate parts, or things that multiply into this number. Okay, so 72, for example, could be broken down into 36 and 2. Okay, 36 in turn could be factored down to 6 and 6, and so on and so forth. Right? We did this when we learned how to simplify radicals. Okay, but the idea of factoring is always that you take a larger number and you break it down into two smaller numbers that it multiplies into. Okay, so polynomial is going to be the same idea, except instead of having a nice clean number like this, we're going to have a variable in the term. Okay, so our factors, for example, if we had the polynomial x squared plus 2x plus 1, okay, now that doesn't look like a number, but if you think about it, it's a number that's in terms of x. So you might get this broken down into two numbers. One would be x plus 1, and the other one would be x plus 1 as well. Okay, and so again, if you don't understand this yet, don't worry, we're going to talk about it, but the idea is this number, x plus 1, times this number, x plus 1, gives us this polynomial. Okay, so now we're not factoring in terms of numbers, but we're factoring in terms of expressions. Okay, x plus 1 being an expression and this x plus 1 being an expression. You multiply those together, you get this new polynomial, this new expression. Okay, just like these two numbers multiply to give this new number. Okay, so that's the idea behind factoring. Okay, so it's a pretty complex process in the idea that we don't work with numbers directly, we're working in terms of expressions. Okay, so it's not very easy to see the factors, so we need some methods to help us learn how to find the factors of a polynomial. Okay, and one of those methods is this method of factoring by grouping. Okay, and so let's look at this example problem. We want to factor this expression. Okay, so again, the idea is we have some number, some expression that's or some number that's described by this expression. Okay, again, it's not very easy to see, but there is a number defined by this expression. Okay, and it's in terms of a. So we want to break down this whole expression in terms of its factors. Okay, the things that multiply together to give this expression. Okay, so in order to do this, we're going to use the factor by grouping method. And how it works is we're going to group this expression into two different parts. Okay, we'll separate into this part right here and this part right here. Okay, these are our two groups. Okay, so now instead of having to try and factor this entire thing and think about all the different polynomials that might work and expressions might work, we just have to focus on these two parts. Okay, these two parts separately. Okay, so let's think about this expression right here, this group, 2a cubed plus 4a squared. Okay, if you think back to our last lesson, we talked about how you could use the common factor method to pull a common factor out. Okay, so if you look at this, you'll realize that a common factor for both these terms is 2a squared. 2a cubed can be written in terms of 2a squared, and 4a squared can be written in terms of that. Okay, so that's going to give us 2a squared times a. Okay, 2a squared times a gives us 2a cubed plus 2. Okay, because 2a squared times 2 gives us 4a squared. Okay, so we're just focusing on this part of the expression right now. We're working on this group. Okay, and we can pull out this common factor and we're left with this. Okay, now we can look at this term over here. So now we're going to pull out the common factor of this group. Okay, and you'll notice that 2 goes into both of these terms. Okay, 2 goes into 4, or sorry, 4 goes into both of these terms actually. Okay, so 4 goes into 4a and 8 goes into 4a, or into 4. So we can write 4, and then 4 times a gives us 4a, and then 2 times 4 gives us 8. Okay, so again, we group both of the expressions and we pull out the common factors of both. Okay, Now notice we can see that this expression right here matches this expression right here. So we got a plus 2 and a plus 2. Okay. Now this is the trick of factor by grouping. Because these both match, okay, this expression in parentheses here and this expression in parentheses here, okay, we can think of it in terms of a distribution. Okay. And to be particular, we can think of it in terms of distributing these guys on the outside. Okay, so notice if I rewrite this entire expression like this, 2a squared plus 4 times a plus 2, and treat that all as one, one expression. Notice how this would simplify. If I was trying to distribute this out, okay, it'd be 2a squared times this expression and 4 times this expression. Okay, so this line right here, okay, this line right here is exactly the same as that line right there. Okay, because if you think about how a distribution works, okay, we'd get 2a squared times a plus 2 plus 4 times a plus 2. Okay, so that's where the trick comes from in factoring with grouping, is the fact that both of these match allow us to rewrite the expression like this. Okay, in terms of the two factors on the outside. Okay, now we have our factored expression. Okay, so this expression times this expression gives us this whole expression up here on top. Okay, so in other words, all of these expressions are equivalent to each other. Okay, so we found our factorization. We factored this expression. This big long expression right here is the same as these two expressions times each other. Okay, we found two factors. Okay, so that's our goal. We've now factored this polynomial. Okay, so let's just quickly review the steps that we took in order to do this. Okay, so with factor by grouping, these are kind of the steps we have to do to use this method. Okay, we're going to learn a whole lot of different methods to factor, okay, in this unit. This is one of the ways, okay, and this is the steps. So you separate the polynomial into two parts. Okay, you just kind of group it off with parentheses. Okay, and think about each expression separately. Okay, then you take out the common factor for each part, okay, and for each of the expressions separately. So if you think about this group of parentheses, you think about this group of parentheses, you pull out the common factors from each group separately. Okay, then you check to see if the two new parts match. Okay, if the two groups of parentheses match, then you can do the factor by grouping method. You can continue on with the process. If they don't match, then you may need to use something else, which we'll talk about later. Okay, but if they do match, then you can use the factor by grouping method, and then think about it like this. So if they do match, that thing in parentheses is the first factor, and then the second factor is the addition of the two common factors you pulled out. Okay, so if you want, you can write this down, or you can just think about it in the steps I showed you before. But these are this is the method we use for factor by grouping. Okay, so write that down if you'd like. Okay, but we're going to go through some more examples so we can kind of practice this process of the factor by grouping method. Another thing to keep in mind is that this only works with quadrinomials. Okay, quadrinomials meaning 4 terms. Okay, why is that? Because with the factor by grouping, you had to be able to separate the polynomial into 4 parts, right? So we had some long expression, okay, whatever it is, and we have to be able to separate it into 2 separate parts. Okay, in order to do that, you have to have 4 terms. Okay, you can't separate the expression if there's not at least 4 terms to separate. Okay, so that's why you have to have at least a quadrinomial in order to do factor by grouping. Okay, and in class, all the examples we'll use will be quadrinomials. Okay, but just keep that in mind. If you have a trinomial or a binomial or anything like that, then you can't use the factor by grouping method. Okay, so has to be done with a quadrinomial because you have to be able to separate. Okay, we will learn some other methods for this unit that will teach us how to factor trinomials. Okay, in fact, we'll do a lot with trinomials. Okay, but for factor by grouping only works with 4 terms quadrinomials. Okay. All right, so let's go through another example problem to make sure we got this down. Okay, so we want to factor this expression 6n cubed minus 42n squared minus n plus 7. Okay, so let's go through the steps. Again, it's a quadrinomial, so that means we can try the factor by grouping method. So first of all, let's kind of separate this expression into two parts. Okay. And so let me actually point out something. I'm going to group this minus sign with the n as well. Okay. Because that minus sign is going to be important. So let's rewrite this down here just to make sure we got this clear. So we got the expression 6n cubed minus 42n squared plus a negative n plus 7. Okay. Now we want to pull out the common factors from each section, okay, or each expression. So this one, you'll notice, has a common factor of 6n squared. So if we pull out 6n squared, okay, that will give us n, 6n squared times n gives us 6n cubed, okay, minus 7, okay. So 6n squared times n times negative 7 gives us that expression above, okay. And then this one doesn't look like it has a common factor, so let's just write it down again, okay, minus n plus 7. Now notice these guys don't match right now. N minus 7 and minus n plus 7 aren't matching expressions. So you might be thinking, oh, okay, then we can't use factor by grouping. But if we rewrite this and pull out a negative sign, okay, or a minus 1 in reality, okay, then watch what happens. We pull out a minus 1. This becomes n minus 7, okay. So now these two expressions match, so the factor by grouping method will work. Okay, so our first factor will be the n minus 7, and our second factor will be the two common factors on the outside. So 6n squared minus 1. So 6n squared minus 1. Okay. Sorry, that doesn't look the best, but you get the point. 6n squared minus 1. Okay. So there's our two factors. Those are the factors to this big long expression. N minus 7 and 6n squared minus 1. Okay? And there we go. That's the factor by grouping method. Okay? So let's go ahead and look at another situation, another scenario. Okay? So we got 2x cubed plus 4x squared plus 3x plus 9. Okay? So we're going to do the factor by grouping method. Okay, so we need to separate our expression into two parts. Okay. And then we need to factor out the common terms. So 2x cubed plus 4x squared, the common factor for this expression is going to be 2x squared. So we get 2x squared, and then 2x squared times x gives us that. And 2x squared times 2 gives us this. Okay. And then for factoring this expression, you'll notice that 3 goes into both. So you get 3 times x plus 3. Okay. All right. So this is a great example of a time when group or factor by grouping doesn't work. Okay. We got x plus 2 in this expression and x plus 3 in this expression. There's never a case where those two will be equal to each other. Okay. So we can't use the factor by grouping method for this problem. Okay. And so if you ever come across that, just write down, we can't do the factor by grouping method. Okay, I don't think there's any like this on your homework, but just keep that in mind, that if these don't match, then either you did it wrong or it doesn't have two factors. Okay, so just so you know, just be aware of that. Again, I don't think we try and trick you on the homework with that, but just so you know. Okay, make sure the factors match. Okay. All right, so let's try one more problem just to make sure we got this down. Go ahead and try this on your own. I believe this problem is on your homework. Okay, but go ahead and try this on your own. I'll set a timer for you. Okay, try and get this one done in 3 minutes. Okay. Okay, so holding up that phone is strangely a workout, but let's see how you did. Okay, so let's go through the problem. So factor by grouping, first step is to group off the expressions. Okay, so we're going to separate it like this. And again, I'm going to keep that minus sign with that 7 in this problem. Okay, so let's rewrite it just to make sure we're clear. We got 4v cubed plus 20v squared all grouped together plus negative 7v minus 35. Okay? All right, so let's look at this common factor right here. So if we think about the common factor, they both are divisible by 4v squared, so we can pull that out. So we got 4v squared times v plus 5. Okay, so v times 4v squared gives us that. 4v squared times 5 gives us that. Okay, and then on this one, we can pull out 7, but we can also pull out a negative 7. So plus negative 7 times v will give us that, and plus 5 will give us that. Okay, so we got matching expressions, so we can do this. Okay, so our first expression will be v plus 5, and the second one will be the stuff on the outside. So 4v squared minus 7. So 4v squared minus 7. Okay, and there you go. There's the two factors to this long expression. Okay, alrighty, so that is factoring by grouping. Hopefully that all made sense. Let me know if you have any questions, and thank you for watching.